Hello everyone, my name is Maria Helena Franciscato. I'm a PhD student at Federal University of Paraná in Brazil, and today I want to present to you our study named Blending Topic-Based Embeddings and Cosine Similarity for Open Data Discovery. So first, for contextualizing this study, we know that as data grows and it needs to be accessible, open data became very popular to make information public and accessible to all citizens, where they can be aware of what is going on in their country. And as open data use increases every day, there's a need to maintain numerous databases for storing important information, and this is not a trivial task. In open data, retrieving the information the user expects requires accessing structured and unstructured data, which lose significance if they are not presented clearly and meaningfully. In short, open data is not only making data available to all citizens, but also give the user conditions to actually use this data and analyze it. But open data portals are actually very complex for regular users. First, because of the amount of data and formats in which these data are published. And depending on the case, the information becomes confusing, becomes difficult to visualize. And this causes a difficulty in finding information too, because the information the user needs may be spread over many different data tables, so a query may return only a part of the information the user would like to see. And as a consequence, it's user responsibility to spend time finding, downloading, and evaluating datasets, and often they cannot do that without help. And finally, all these problems may impact in scientific cooperation regarding the analysis and integration of heterogeneous data sources. If finding information in open data portals is complex, then studies that rely on this information may be affected, as well as solutions that could be applied in our society. So these challenges involving open data could be minimized if we could decrease the manual work when searching for information. And a way to do that is having some discovery engine for recognizing which data source best fits our questions and retrieving this best source at first hand. So as we can see in this figure, given a question informed by the user, the discovery engine could analyze all possible data sources to find the one that is more likely to answer the question. And this is what we are proposing in our study, a source discovery engine for finding this best source among a set of candidates. And in our case, we propose to do that by using topic-based embeddings and cosine similarity. So in short, we aim to use these methods to measure how semantically close each candidate source is from a query and pick up the most similar one. Before explaining in details our approach, it's important to talk about some methods involved in this study, like cosine similarity. This method measures the similarity between two vectors being compared. So in this example here, we have 4 documents, and we want to know how similar the document 1 is from document 2. So we count the frequency of each term in these documents. For example, the word hockey appears 3 times in document 1 and twice in document 2. And we do this count for all words to obtain one term frequency vector for each document, and applying these values to cosine equation, the similarity between the two documents is 94%. And the other method we used was proposed in a recent study, and it's called LDA Word2Vec. It joins topic modeling from LDA algorithm and Word2Vec embeddings to classify an input sentence into a given document. And here we have some steps that summarize how this hybrid method works. First, all candidate documents are preprocessed to obtain all tokens or all words that represent them. And in a second step, The LDA algorithm is applied to find the main topics in each document, being each topic composed by relevant words and their proportion in the document. After finding the main topics, the algorithm extends each topic word with word2vec. This means that if a topic contains the word education, for example, through word2vec we can find other similar words such as teaching, schooling, study, and so on. So after this word2vec extension, each document is now represented by extended words like teaching in this example and original topic words like education. The algorithm creates triples that put together each original word with an extended word, also putting a multiplied score in the triple. So after this step, each document is represented by several triples. And the final step is then testing an input sentence, assigning it to the topic whose words show higher probability. So considering these concepts I've mentioned in our study is a search discovery approach based on cosine similarity and LDA word2vec. We adapted and joined these two methods to deal with our case study, which is open data. Obtaining this model here, you can see that we consider an input sentence and a set of candidate sources represented by ICEIS, from which we should extract the best one, and two components concerning LDA word2vec and cosine similarity. And the output from these two components are probability arrays that we use to select the final source. So as there is much content in this figure, I'm gonna explain it step by step in the next slides. Let's say, for example, that the user wants to know how many rural schools have computers, and we have these four candidate sources here. Our goal is to discover which one of them is better to answer this question here. And just to simplify our example, let's consider only the candidate sources 1 and 2. Let's say that the candidate source 1 contains information on school census, and candidate source 2 contains information on environmental indicators. So next, the input sentence and the candidate sources must be preprocessed to obtain the most relevant set of tokens from them. So from the input sentence, these tokens, the resulting tokens might be rural, school, and computer. And from candidate source 1, which contains information on school census, the tokens might contain university, students, class, and many other words. And from candidate source 2, the tokens might contain words like tree, deforestation, Amazon, and many others. These tokens go to the LDA component, which performs topic detection in each one of the sources. So as you can see in the figure, from the CS1 tokens represented in red, we detect these topics and proportions, and from CS2 tokens, we detect other topics and proportions with LDA. Next, we perform the word2vec extension. This component gets all topic words from LDA and outputs words that are similar to them by using word2vec. So for each original word W, we get an extended word EW, and the scores from these two words are multiplied to obtain a derived probability represented by DP in this figure. So for example, if we have an original word education, we derive teaching, schooling, school, and many other words through word2vec. So the output from this whole component are several triples for each candidate source. And after extracting the triples for each candidate source, we try to match them with the input sentence. Specifically, we try to find each input sentence token in these triples. We try to find rural, school, computer, in all triples from all candidate sources. And when we find one or more words, like here, we have school, we start calculating probabilities for each source. For example, for candidate source 1, the words rural, school, and computer were found with these scores, respectively. And for candidate source 2, the words were found with these other scores. We can see, for example, that the word computer received a very low score for this source 2. That's because the word was not found in any triple, so we put a default value. And with this step, we already have all probabilities from the LDA Word2Vec module, but we still have to aggregate the cosine similarity that is on the right part of the figure. At the same time the LDA and Word2Vec module runs, the cosine similarity module is executed too. So the tokens extracted from the candidate sources go through a vectorizer step responsible for counting the word frequency in the source content and building frequency vectors. For example, for candidate source 1, the word education appears 24 times, the word students appears 12, and so on. And we do this count for all candidate sources and for the input sentence too, as you can see here. So the cosine equation receives the input sentence vector and a source vector for measuring the similarity between them. And through this equation we get these results. The similarity between the candidate source 1 and the input sentence is 85%, while the similarity between the candidate source 2 and the input sentence is 70%. Now we only have to aggregate these scores in the probability arrays for each source. We added the cosine scores in the respective probability arrays. So the probability array for source 1 receives 0.85 and the array for source 2 receives 0.7. And the last step of our approach is to obtain the average for each source array. As you can see in our example, the source 1 gets the higher average, so it is the selected source. So we can say that the candidate source 1 is the one that is more likely to answer the user question. Talking a little about our experiments, we applied our approach to discover the data source that best matches an input question, considering 8 possible data sets extracted from Brazilian open data. We used FIES, INEP, ProUni, School Census, CadÚnico, IBGE, DataSUS, and IBAMA. And from these 8 possible data sets, the first 4 contains educational data from different contexts in Brazil. And here's what we used in each step of our approach. The content from each candidate source was extracted and put in a CSV file, so we had one CSV for each source. For preprocessing this content, we apply techniques such as lowercasing, removal of stop words, stemming, removal of special characters, tokenization, and for topic detection, we used the Gensyn implementation of LDA multicore, which is available online. For Word2Vec extension, we use a fast text Portuguese pre-trained model, which is also available online. And for measuring the similarity between a topic word and words from fast text model, we applied a method from Word2Vec called similar by vector. And finally, for vectorizing the tokens from candidate sources and the input sentence, we used the counter method available on Python for obtaining all term frequency vectors. And just recalling, our approach was evaluated concerning source discovery, the capability to choose the most likely dataset to answer an input query, and considering the 8 candidate datasets, we elaborated test sets contained 48 and 74 questions respectively, to which a source should be inferred. So here in table 1 we have an examples of the test questions where each question has a correct answer or a correct source. You can see that for the question how many rural schools have computers, the right source would be school census. And all questions and their correct answers were defined manually based on indicators available on data monitoring platforms. Talking about the evaluation and results, the evaluation was performed in 3 rounds. So here we have results from the first round. In the first round we used all 8 candidate sources and the test set containing 48 questions. And when using only cosine similarity, the accuracy reached 87.5% of the test questions, whereas for LDA word2vec, the accuracy rate reached almost 80%. And when testing our approach that blends the 2 methods, the classification accuracy was quite higher, reaching almost 94%. For assessing the approach consistency, we conducted a second round of evaluation using the test set containing 74 questions and the same 8 open data sources. The results for LDA, word2vec, and cosine had a little variation, but yet our model's accuracy was the best, reaching almost 88%. This decrease can be explained by the structure of some test questions which contained more general content. For example, some questions contained words that are common in many candidate sources. And in the third evaluation round, we decided to remove 3 of the most distinctive data sources from the pool of candidate sources, leaving mostly the data sets related to education. This means that we used 5 data sets and 4 of them contained education data. Our objective with that was to verify if the classification accuracy would be good with data sources containing very similar content. And the results proved that our approach was again the best when compared to the isolated methods, reaching an accuracy above 93%. And here we have a comparison among the classifications performed in third evaluation round with 5 data sets. We can see that our approach made the correct classification for most questions in the test set, and we had no incorrect classifications for sources such as school census and CAD único. And from these experiments we concluded that our hybrid approach was able to discover the most related data source for a question even when the sources had very similar content. As conclusions from our study, we presented a source discovery approach that joins topic-based embeddings from LDA, word2vec algorithm, and cosine similarity, and the classification results showed an accuracy above 93%, a superior rate when compared with the methods when compared with the isolated methods. And it's important to highlight that the evaluation considered 8 data sets and half of them contained information on education, so we can say it was a classification task more difficult than if all sources had distinct content. So we see that this approach has potential to improve open data transparency and user support. And as future work, we aim to implement a unified solution that combines different advantages from each method. For example, majority vote. We believe that when the combined methods disagree with respect to the classifications, some voting mechanisms could choose the most voted class, which could improve the accuracy even more. And that's it. Thank you very much for your attention. This is my contact information. In case you have some questions, some suggestion, I'd be very glad to help. Thank you all.